We're going to continue looking at 2.1. Today we're going to look at two formulas. We're going to look at what's called arc length. Just to kind of show you quickly, if you draw an angle in a circle, that part in red is an arc, and I want to figure out how long that is. Okay, it's going to depend on two things. It's going to depend on how big of a circle did you draw, and how big is this angle that you drew in the circle. Right? So we're going to learn a formula for that. And the other thing we're going to learn a formula for is the area of that part shaded in blue. Okay, that's called a sector. It's not a triangle. It does have two sides that are straight, but the third side is curved. Right? So it's kind of like it's like a piece of pizza or something. That's the shape of a sector.
What is that blue part called?
That's the area of a sector. Okay, so that shape that's in blue is called a sector. Right? Yeah, just think of it like a piece of pizza. A circular piece of pizza. That pizza. All right, so we're going to start out with the formula for how you find the length of that part in red. Okay, it's called arc length. All right, so the first thing we need to write down is the following. Arc size and angle size are directly proportional. It says proportional at the end. Ran out of space. Okay, so arc size and angle size are directly proportional. Okay, so what that means, if two things are directly proportional, as you change one thing, the other thing changes exactly the same way. So let's look at kind of a picture of that and see what that means. Arc size and angle size are directly proportional. So I'm going to draw a couple circles. And let's draw an angle inside that circle, like that. Okay. What is the size of that angle that I drew?
90.
Yeah, it's a 90-degree angle. Now, in the other circle, I'm going to double the size of the angle. So I'm going to draw it. There's the initial side. There's the terminal side. Okay. What's the size of that angle if it's double the one on the left?
180.
That's 180. Okay, so everyone agrees that the angle on the right is double the size of the angle on the left. Okay. So now, instead of looking at the angle, I want to look at the part in red, okay, the arc. How much of the circle does that red arc take up? A quarter. So the arc is 1/4 of the circle. All right. Now let's see what happens to the arc here. We doubled the size of the angle. If these are directly proportional, then the size of the arc should have doubled as well. Okay. If it doesn't, then they're not directly proportional. How much of the circle does that arc take up? It takes up half. It's a half circle. So the point here is if you have an angle and you double its size, then you also double the size of the arc. You went from 1/4 of a circle to taking up half a circle. If you made this angle half as big, what would happen to the arc? It would be half as small. Right? So if you make the angle half as big, then the arc would get half as big. If you make the angle 5 times as big, you'd make the arc 5 times as big. That's what directly proportional means. As you change one, the other one changes exactly the same way. Right. And just to write the word a little neater, if you look at that word, does anybody notice another word that's in that word?
Pro.
Yes, pro is in there. So is port. So is or.
Portion.
Proportion, yeah, that's the one I'm going for. So proportion. So when two things are directly proportional, you can set up a proportion to find one when you don't know the other. A proportion generally looks something like that. In a proportion, you usually have 4 spots. 3 of them are things that you know, and 1 of them is something you don't, and then you can solve. Okay? But you can only set up a proportion when 2 things are directly proportional. But these are, okay? And we just showed that. So let's look at a diagram. And what I've done is I've drawn a circle with 2 angles. Each angle has a name, theta and theta 1. Not sure if we talked about it, but theta is just a Greek letter that represents the name of an angle. Okay, when you do trig, like in algebra, you use x a lot. It's kind of the general letter for a variable. Theta is the general letter for an angle in trig, when you don't know it. Okay, so I have an angle here, and I have an angle here. Theta, theta 1. I also have arcs that are connected with each of those angles. Arc S goes with angle theta. Arc S1 goes with angle theta 1. Let's see.
Thank you.
And R, that just stands for the radius of the circle. All 4 of those lines coming from the center, they're all R. All right. So what we want to do is come up with some type of connection between basically these 4 things. Because those are what are going to be in my proportion. I'm going to have 4 spots. 1, 2, 3, 4. And I need to fill those in somehow. When we fill them in, it doesn't matter exactly how we set it up. What matters is we set it up the same way on the left and on the right. So like if we do arc over angle on the left, we need to do arc over angle on the right. Okay? So 2 pieces of these information are going to go on the left, 2 pieces are going to go on the right, and we just need to set it up the same way on each side. So out of the 4 things I have circled, what could I put on the top in the left to start to set up a proportion? Yeah.
The arc?
Sure. Which one?
The first one, just S by itself.
S by itself. Okay. So we put the arc in the top on that side. So what's going to go in the top on the other side? S1. Okay. If the arc is in the top on each side, what's going to go on the bottom? Let's start with the bottom on the left side. Yep. Theta. And what's going to go on the bottom on the right side? Theta 1. And there's lots of ways you can set that proportion up as long as you're consistent. If you put theta in the top on the left, that would have worked too. You just have to make sure you put theta in the top on the right. The key is what's going to always happen is what's on the diagonals is going to end up being the same, as long as you set it up consistently. That's what's important. The diagonals will be the same. All right. Now, having a proportion like that, that's not really helpful because it has 4 letters. It has 4 things you don't know. If you want to make a proportion useful, you have to fill in a fact on one side that you know is true. Okay, so let's say I wanted to create a proportion that converted between feet and inches. Okay, if I gave somebody that, that's useless. It doesn't have any information in it that they can base anything off of. I need to fill something in on one side that I already know is true. It can be anything I know about feet and inches. I just need something that's true. What is something that's true that relates feet and inches? Anything? Yep?
1 foot is 12 inches.
Sure, that's one fact that is true. What's another fact that's true about feet and inches?
Feet is 1 foot.
10 feet is 120 inches. Yeah, any fact that you want. Preferably something simple, but anything will work. Okay. Now, once you put in something true on one side of the proportion, you can put in something you don't know on the other side. Like let's say I want to know in 8 feet, how many inches are there? Okay. As long as this fact on the left side is true, it'll help me figure out the right side. Does anybody remember how you solve a proportion? Yep.
Cross multiply.
Yep, you would cross multiply. So I'm not really interested in solving this, but you basically just do 8 times 12 equals 1 times x. So the answer is just 8 times 12. And that would tell you how many inches are in 8 feet. Okay, but this was the whole key. We started with something we already knew to be true. Okay. And we got to do the same thing here. We have to start with something that we know is true. Now, just because I put 1 foot and 12 inches here, does that limit what number I could put on that side? No. That's just a true fact. I could put an 8 here, I could put a 10, I could put a 13, I could put a 14.7. This is just a fact that we know is kind of our starting point. You can still put anything you want on the other side once you have your starting point. Right. So this is going to be our starting point. We're going to suppose that theta 1 is 1 radian. Why 1? Well, I don't know, why did somebody give me a 1 when we did 1 foot and 12 inches? Because 1 is an easy number to work with. Right. Now, if this angle is 1 radian from there to there, it automatically makes this arc a certain size. And we mentioned that yesterday. Okay. If you have a picture of 1 radian, does anybody remember what the length of that arc is the same as in the picture? Yep.
It'll be 1, because it's the same as the radian.
It's the same as the what?
Radian.
Same as the, okay, so yeah, you're thinking of on a unit circle. We don't know for sure that that's a unit circle. But even if it's not a unit circle, we still know that this is the same as something else. Yep.
As the angle?
Only on a unit circle, that's true. Yep.
Would it be equal to r?
It'd be equal to r, yes. That's going to be our starting point that we can use. That's going to be like our 1 foot is 12 inches. If that's 1 radian, then the length of s is automatically the same as the length of r, whatever r is. Right? So if theta 1 is 1 radian, then s is automatically the same as r. And the reason that's important is because they're going to give you r in the problem. So now you have a piece of information that you can use. Right? So let's fill in this fact right there. That's going to be my starting point. Okay, that's just what I circled. That's like my 1 foot equals 12 inches. The left side, we're just going to leave it. That's going to be the stuff that we don't know, that we're going to have to fill in for. On the right side, we're going to change this one. We're going to change S1 to R, and we're going to change theta 1 to 1 radian. So again, that is my 1 foot equals 12 inches. That's my true fact based on some definition. Just like this. Why is 1 foot equal to 12 inches? It's a definition. Why is the arc equal to the radius? It's a definition, as long as you have an angle of 1 radian. It's a definition. All right, so now let's cross multiply and solve it. What's s times 1? S. And what's r times theta? What is it?
It would be r
And then theta. So if you cross multiply, that's what you get. S equals r theta. And that, I'm just going to move that over here. That is the arc length formula. S equals r theta. So S is the length of the arc. R is the radius of the circle that you're working with. And theta, what did we say that a Greek letter is always used for in trig? How about more generally? Theta represents
Unknown angle.
an unknown angle, yeah. So theta is an angle. But we've got to be a little bit careful with the angle in that formula, because when we set up our true fact on the right side, what did we assume about the angle? Yeah, it will always be positive because we're dealing with, in this case, yeah, it'll always be positive. Something else we assumed about it though too. Yep.
It's half of the original video.
Oh, we assume that it's one.
One what?
Right.
Radian, right? We assumed that the angle was 1 radian. It's kind of like if you set up this proportion, you assumed that you're working in feet and inches. If you're not working in feet and inches, then this isn't what you want, right? You assumed that it was feet and inches. We assumed that it was radians when we set this whole thing up. So the angle has to be in radians. If they give you an angle that's not in radians, we need to fix that. So it is. And the way that the formula works, it has 3 variables in it. They're always going to give you 2 of them, and you're going to solve for the 3rd one. So you could solve for any of them. You just plug in the 2 that you know, and then find the one that you don't. All right. Let's try an example. Okay, so for this one, I wrote out a description of what we're going to do. And did I put a picture? No, that's the next one. Okay, so sometimes you might see a picture of what they want you to do. Sometimes you might just see a description. So this says, find the length of the arc. So we've got a circle with an angle of pi over 3 radians. And the circle has a radius of 4 inches. Find the length of the arc. If you want kind of a visual for what we're doing, I mean, we can do it. So there's your circle. You've got an angle inside the circle. That angle inside the circle is pi over 3 radians. And the radius of the circle is 4 inches. We are finding the length of that part in red, right there. All right. So we are going to learn 2 different formulas, so we're going to have to know which formula to use when. Right now we only know one, so it's pretty easy to figure out which formula we're going to use. What is the formula that I need to use to figure this one out? What's the equation?
S equals
Yep.
S equals 1 theta.
S equals R theta. Okay, so that's the formula we need. Now we'll fill in everything that we're given into the formula. Did they give me S? No, that's the question. Find the length of the arc. So we don't know S. Did they give me the radius? Yeah. What's the radius in this one?
4 inches.
4 inches. And did they give me theta? Yep. What did they give me for theta?
Pi over 3.
Pi over 3. What's supposed to be the unit on theta? Radians. What unit did they give me? Radians. Perfect. So they did give me the right unit that I need for that formula. Okay, so we're going to multiply. If it messes you up because the 4 is not a fraction, well, you just make it a fraction. Multiply straight across. So when we multiply in the top, 4 times pi, we just leave that as 4 pi, we don't round it. And what do you get when you multiply what's in the bottom? 3. Now, because this is a measurement, right? S is the arc length. A measurement needs a label on it. What should be the label on 4 pi over 3? Inches. S is a length in inches in this problem. R is a length in inches. Theta is an angle in radians. Okay, so these two would always have a label of inches, feet, centimeters, whatever that is. This one has a label of radians. You just have to look back at your problem and use the label they use. And that's it. So the length of that arc is 4 pi over 3 inches. If they wanted a decimal, they would put in the directions round to 2 decimal places. 4 pi divided by 3, it's about 4.19 inches. Okay. Any question on that one? All right, let's try this one. Actually, I think it's below it. Yeah. Okay, so it's the same directions as last time. Find the length of the arc. But this time they've given you the question in a different format. It's more of a visual this time. All right, so again, first thing, decide on what formula you're going to use. What's the formula that I need for this one? Right. If you see a problem that has something to do with arc length, it's always S equals R theta. If you see a problem that has something to do with area, well, that's the last one we're going to do. So it's S equals R theta. And now go through each letter. What did they give me for S?
Nothing.
Nothing. That's the question. Find the length of the arc. What did they give me for the radius? 8 feet. And what did they give me for the angle? They gave me 130. What's the unit on that?
Degrees.
Degrees. What is the unit supposed to be? It's supposed to be in radians. So what I'm going to do off to the side is convert that to radians before I fill it in. What do I multiply and divide by to change the degree into radians? Yep.
Multiply by pi divided by
Yep. Multiply by pi, divide by 180. I'm not going to round that off. The only thing I'm going to do is divide the top and bottom by 10. And even if you didn't divide by 10, you don't have to. It just makes the numbers a little smaller. But if you didn't divide by 10, you'd still get the same answer. Okay. So converting 130 degrees into radians, it's 13 pi over 18. So there's my radius. There's my angle. Is there anything that I can reduce both the top and the bottom by? No? No number that goes into both of them? Yeah? 2, yeah, into, that was my hand. So yeah, 8 and 18 are both divisible by 2. How many times does 8 go in, 2 go into 8?
4.
And 2 into 18? 9. Okay. Let's multiply what we have left. What's 4 times 13?
52.
So that's 52 pi. So 52 pi divided by 9. And again, we do need a label on that. 52 pi over 9 was what letter? That's S. S stands for arc length. What are my lengths in this problem? Feet. So 52 pi over 9 feet. Okay, so that one had one extra step compared to the last one because you had to change degrees to radians. Any question on that one? All right, let's try one where we do something besides just solving for S. Let's try one where they say find the angle. Okay, so I've already written down the formula. I won't have that on the test, but if you make a reference sheet, you can put the formula on that. All right, and let's start filling in what they give me. All right. What did they give me for S?
Pi over 4
Yep.
centimeters.
The arc length is how much?
Pi over 4 centimeters.
Yep, pi over 4 centimeters. What did they give me for R?
12 centimeters.
12 centimeters. Now, this would be a little tricky, but these do have to be the same unit. So if they gave you one and said like the arc length was pi over 4 meters and the radius is 12 centimeters, that's a problem. You need everything in the same unit. I don't think they generally will do that though. Okay. But they're in the same unit, so that's good. And what did they give me for the angle?
We're trying to find it.
We're trying to find it, so we don't know. All right. So how are we going to get theta by itself on the right side?
Divide by 12.
Yep. So we can divide by 12. Dividing by 12 on this side is the same as just putting a times 12 in the bottom. So 12s cancel. And what do we end up with for an angle on the left?
Pi divided by 48.
And what's the unit on that? So you think it's in, you said centimeters? Okay. Anybody think it's not centimeters? Yeah?
Radius.
It's in radians. Okay, that is theta. Remember, theta is an angle. You don't measure angular, you don't do angular measurement in centimeters. You do that in radians. So should I put RAD? No. Okay, we don't have to put any label on that because it is in radians, and it's always understood RAD is there. Okay. Any question why that's not centimeters? There's only 2 letters in that problem that are centimeters, S and R. And we weren't solving for either one of those. All right, so that's how you can find R. And let's finish up. Oh no, that's how you find theta. Let's finish up with one where you find R. Okay, so find the radius. Okay. What did they give me for S this time?
15 feet.
Yep, 13 feet. What did they give me for R?
Figuring out.
Yeah, we don't know. That's the question. Find the radius. And what did they give me for the angle?
36 degrees.
36 degrees, but when we convert that to radians, that's going to be pi divided by 5. Okay. We'd multiply by pi and divide by 180. When you reduce it, that's what you get. Pi over 5. If you want to check it, just do 180 divided by 5 and see if you get 36. And you will. Okay, so we converted our angle into radians. Now we have to get R by itself. This time there's 2 things we don't want. We don't want the pi or the 5 on that side. Does anybody remember how you can get rid of the pi and the 5 at the same time? Yeah?
Multiply by 42.
Yep, multiply. So what would you multiply by?
5 over 5.
Yep, multiply by the reciprocal. Okay. Multiplying by the reciprocal gets rid of the pi's and the 5's at the same time. All right, so now we'll do that up. What's 5 times 13? 65. So my radius is 65 over pi. And do I need a label on that? Yeah, what should my label be? Feet. Okay. R is a length measurement, so you need feet. Any question on using the S equals R theta formula? Okay, now let's look at the last part, which is area of a sector. So the first thing I want to do is figure out, is there a connection between the size of the angle and the size of the area? We already know there's a connection between the size of the angle and the arc. What was the word we used to describe those two things? They were?
Proportional.
Yeah, directly proportional. We want to see if area is also directly proportional. So let's draw the same kind of picture and take a look. So here's two circles. Okay, I'm going to draw an angle in that one. Okay. How much is my angle in that picture? 90 degrees. And now I don't want to focus on the arc. I want to focus on what part of the circle that shaded region takes up. So not focusing on the arc, I'm focusing on the area. So if you cut that section out, how much of the circle would you be removing?
A quarter.
You'd be removing a quarter of it. So now, let's see what happens if we double the size of the angle. What's the connection to the area? Okay. How big is that angle?
100.
Right. So if we double the size of the angle, it becomes 180. And the question now is, if you double the size of the angle, what happens to the size of the area created by that angle? Right, that would end up being half the circle. So what does that tell you about the size of your angle compared to the size of the area? Yeah, it is directly proportional again. If you triple the size of your angle, you will triple the size of the area that's covered. If you make your angle half as big, you'll make the area half as big. They are directly proportional. So that means we can set up a formula for this one exactly like we did the last one. Right? We're going to have a proportion. We just have to figure out something that we know is true, put that on one side, and then we can leave the other side the way it is and cross multiply, and we'll get a formula. All right, so here is the same kind of picture, except now I'm not focusing on S, which is the arc length. I'm focusing on area. So I got two angles, theta, theta 1. Theta carves out an area of that size, and theta 1 carves out an area of that size. So let's set our proportion up first, and then let's see if we can figure out something that we know is true and fill that in on one side. Okay, we got to get like our 1 foot equals 12 inches. We got to start with something. These are the four things that are going to go in my proportion. Anybody think they could tell me what I could put on the left side? Yeah.
Area over theta.
So yeah, we could do area over theta. So we did A over theta. Now when we set up the right side, we just have to set it up exactly the same way. Yeah, do you want to tell me the right side? Yep, A1 over theta 1. When you write something like that, what you are saying is these two things that I just wrote down are directly proportional. That's what that means. But to make that useful, you've got to fill in a fact that you know is true on one side. All right? It can be any fact. So you can suppose that theta 1 is anything that you want, right? As long as you then fill in the right thing for A1, right? Just like with the feet and inches. If you wanted to give me a true fact about feet and inches, you could give me 5 feet, but now you have to put the right amount of inches. You'd have to put 60. You can't put 70, that's not true. 5 feet is 60 inches, right? So what we're going to do is we're going to suppose that theta 1 is 2 pi radians. Okay, I could suppose anything I want. But now that I'm supposing it's 2 pi, I need to figure out the right thing for A1 to make this a true statement. Let's go back to our picture, and I want to see how big 2 pi is. Does anybody remember what's 90 degrees in radians? Pi divided by 2. So that's 90 degrees. How about 180? That was pi. So then we're going to work with 2 pi. Right? So if I was going to draw a picture of that one, how much of the circle would an angle of 2 pi take up? It would take up the whole circle. My angle would look like this. The initial and terminal side would be right on top of each other. And the area would be the whole circle. So if my angle is 2 pi, then my area is, let's say, the whole circle. So what that means for what we're filling in, okay, for our true fact, the area, the angle is 2 pi, the area is the whole circle. Now you can't fill in the words whole circle in proportion. You need to fill in like a formula. What we need is the formula for the area of a whole circle. That's what we need to fill in right there. So if that's 2 pi, then the top is the whole circle. What's the formula for the area of an entire circle?
Pi r squared.
Yes, pi r squared. So this is like your 1 foot, 12 inches. Angle that goes all the way around means whole circle. So let's fill that in. Okay, the left side, we're just going to leave that the way it is. That's going to be the information they give you in the problem. The right side, that's our true fact. Theta 1 is 2 pi. Oops. That goes in the bottom. And A1 goes in the top, pi r squared. Okay. Before I cross multiply, does anybody notice anything that's going to happen? Yeah?
You can cancel the pi's out.
Right, pi's are going to cancel out. And now let's cross multiply. What's a times 2? 2a equals, what's theta times r squared?
R squared.
Yeah, it's just r squared times theta. So what we have there is a formula for double the area that you want to find. How could we get a formula for just the area, not double area? Yeah? Yeah. Divide each side by 2. And the way that you're usually going to see it in the book, instead of dividing by 2, in the book they say take half. That's the same thing. So the area is 1/2 r squared theta. That's the area of a sector. So now if you see a problem in the book that involves area, you're using that. If you see a problem that involves arc length, we're using the other one. Okay, so A is area. R, what do you think R stands for? The radius, that's the size of the circle. And theta, that is my angle again. And we're going to go back up, because when we set this up, we assumed something about the angle. What did we assume about it?
2 pi.
2 pi radians.
Right. Well, the fact that we picked 2 pi is just like the fact that we picked 1 foot. We could have done 2 feet, 3 feet, 4 feet. We could have done other things for the number for the angle. But the important thing is we assumed it was in radians. Okay? So that means when we use this formula, it has to be in radians. Okay, and this one works just like the last one. It has 3 variables. They'll always give you 2 of them. You fill in the 2 that you know, and then you find the one that you don't. Okay, so this is the formula for finding the area of a shape that looks like that. The shape has 2 straight sides and 1 curved side. It's called a sector. So it's kind of like a triangle, but it's just one of the sides is curved. Okay. Any question on the front one? So let's try this one. Find the area of the sector. Okay. Now, by the question, you need to know what formula to use. Right. Based on what they're asking you to find. I mean, if all you saw was the picture, well, that's not enough information. You potentially could do this problem using either formula. Depends on what they want to know. But now we know what they want us to find. Okay. So what's going to be the formula that I use here? Yep.
Area equals 1/2 radius squared times theta.
Times theta. Okay. And now start filling in everything that they gave us. What did they give us for the area? We're finding it. They didn't tell us that. What did they give us for the radius? 4 centimeters. And what did they give us for the angle?
Pi divided by 6.
Okay, pi divided by 6, what?
Radians.
Radians. And what was supposed to be the unit that we need?
Radians.
Radians, so it's fine. Okay, so pi over 6, that's what we need. Let's simplify it. What's 4 squared?
16.
And then half of that?
8.
So 8 times pi over 6. And if we get a fraction we can reduce, we just reduce it as much as we can. What does 8 pi over 6 reduce to?
4 pi.
Over what?
3.
3. And just like we did before, we need a label. What did we just find? We found area. So you need to think about how you would label something that is an area. Centimeters squared. Right. Centimeters alone is a length. Square centimeters, that's an area. Okay. Any question on that? All right, so that was finding the area, and they gave us a picture. Here's another one where they're giving us a picture, but they're asking us to find the radius. So let's see how we do. Okay, so we got our formula. What are we going to fill in for area?
8 pi over 3 inches squared.
Right. How do we know that that's the area, besides where it's placed in the picture? Let's say they put it on the outside.
Inches squared.
Right. We know it's inches squared, so it has to be an area. So we're going to fill in 8 pi over 3 for the area. The 1/2 we're going to copy down. What are we filling in for the r? We don't know. So we're going to leave that. And what are we filling in for the angle?
45. Or no.
we have to convert that to radians. Yes. So the angle is 45 degrees, but just remember to convert that over to radians. And when you simplify, what are you going to get for an angle?
Pi over 4.
Yep, pi over 4. Okay. So now there's 4 things we need to get rid of on that right side. The 1/2, the exponent of 2, the pi, and the 4. All of those need to go to the other side. I wouldn't do them all at once. Let's start with the pi over 4. We did something kind of like that earlier. How could we get the pi and the 4 on the other side at the same time? Yep.
Multiply by 4 over pi.
Yeah, we can multiply by 4 over pi. That doesn't take care of everything, but at least it takes care of that and that. And what happens on the left side?
The pi's cancel out.
The pi's cancel here too. Okay, so now you're left with 4 times 8 is 32 over 3 equals 1/2 r squared. All right, so now we have 2 things left. The 1/2 and the exponent of 2. Which one do we have to get rid of next? We have to get rid of the 1/2. Yep. How, and again, I would think of as multiplying. What could you multiply each side by that would get rid of 1 over 2?
2.
Yeah. So multiply each side by 2 times 2. Half of 2 is 1. That's gone. And what's 32 times 2? So 64. And then the bottom is just 3. Okay, so now we have our radius squared. I got to get rid of that exponent of 2. Okay, how do we get rid of squaring? Yep.
Square root.
Yep, we take the square root. And when you have a fraction, the way that you take the square root of it is you do the top part and the bottom part separate. So that is your radius. It's not simplified, but that's what it will be. It's the square root of 64 over the square root of 3. Okay. Anything there that you can simplify?
Square root of 64.
Yep, what's the square root of 64?
8.
8. Okay, so that's a little bit better because we simplified the top. Now, this is something that you would have talked about in like Algebra 2. There's something not right there. We didn't make a mistake. It's just not something you're supposed to leave like that. Does anybody know what isn't good about leaving our answer like that? Yep.
The square root's in the bottom.
Right. We generally don't leave square roots in the bottom of fractions. That's not a trig thing. That's just it's like an arithmetic thing. Does anybody remember how you fix having a square root in the bottom? Okay, so we have to multiply the top and the bottom by something. But it has to be the same thing, because you can't, if you multiply by a fraction by something that's not the same in the top and the bottom, then you're changing the fraction. Okay, we're not changing the value of the fraction, we're just kind of manipulating the value to look different, but it's still going to be the same value. It's kind of like if I had 3/5 and I multiply by 2 over 2. It's still the same thing that I started with, I just kind of manipulated it to look a little different. Okay, but 3/5 and 6/10 are the same. So we have to kind of do the same thing here. Does anybody know what we're going to multiply top and bottom by? Yeah?
Would you multiply by 3 so you can get the denominator to a nice square?
Not quite. If you multiply by 3, you'd have this. You'd have 24 in the top, and then you just have times 3 in the bottom. But we do want to get that denominator to be a nice number we can take a square root of. Yep. The square root of 3. Yes. So now in the top, you have 8 square root 3. And in the bottom, the square root of 3 times the square root of 3, you can combine those together and make that the square root of 9. Now, what's the square root of 9? 3. So your final answer is 8 root 3 over 3. And remember, that is a radius. Does a radius need a label? Yes. What should be my label on the radius? Just inches, yep, not inches squared. Okay, so we really finished the part that I taught you at like this step right here. Everything after that is simplifying a square root in the denominator. Okay. But that's how you do it. And I usually combine some of those steps together, but I just did them all out so you could see them. All right, so when you have to solve for r, that's potentially the longest one because of that exponent of 2. That can make things a little longer. All right, so any question on using the area formula to solve for any of the variables? All right, so let's talk about a couple questions you're going to see in the homework. One of the questions in the homework has to do with the hands of the clock moving. And they say something like, the minute hand starts at 12 and it ends at 4. And they're going to ask you how far the tip of the minute hand moves, like that. Well, the tip of the minute hand is making a path that's something we talked about today. The tip of that minute hand is in what shape as it moves? It's an arc. So you're basically finding the length of the arc. To find the length of the arc, you need those two things. In this clock problem, what would r be? I mean, we don't have a number, but I mean in general, like what, if you're thinking of the objects in this problem, what object is the radius?
The hand.
What about the hand?
The length.
The length of it, yeah. The length of the minute hand, that's the radius. Yep. And then the angle is what's right from there to there. Now, like on a clock, the nice thing is everything's equally spaced. So this is basically 4 sections of the clock that you moved. How much is each hour? Think about it in terms of like an angle. Each hour on the clock is a certain amount of degrees. How much is it?
15 degrees.
30.
30, right? Each hour is worth 30 because if you go from 12 to 1, that's 30. 12 to 2 is 60. And 12 to 3 o'clock, that's a 90. So if you think of that as a 90, each section is 30, 30, and 30, and then you're going one more section. So what would be the angle from 12 to 4? That's a 120 degree angle. Okay. Now you've got your angle, you've got your radius, you can easily figure out the problem. Right. Another one they're going to give you, I think it's about a pendulum swinging back and forth. Okay. As a pendulum swings back and forth, what shape does the tip of the pendulum make? It makes an arc, right? It's just like the clock. So as it swings back and forth, it makes an arc. What would be your radius when a pendulum is swinging back and forth? Yeah.
The length of the
Yeah, the length of, whether it's on a string or whatever it is, whatever the length of from the point where the pendulum is mounted to the tip of the pendulum, that's your radius. And then your angle, well, if they said the angle is 40 degrees, they're talking about from there to there, swinging 40 degrees. So you know your angle, you got the length of the pendulum as your radius, you can find the length of the arc. Okay. So I think the last 4 questions have to do with word problems like that. All right, so that's the homework for tonight. So it's the same PDF as last night. 2.1 part 3, or part 2, sorry. And it's 71 to 87 odd, and 91 to 94 all. Okay, so tomorrow we'll finish up 2.1, and I will be after school in case anybody needs extra help.